I just want to make a quick video saying what we can't do yet, because sometimes in math, once you solve a big problem like we did in the previous video with a second order homogeneous differential equation with constant coefficients, you feel like you can solve everything, right? We have a general solution format. We actually can't. There's a couple cases where it doesn't work. So what was nice about our differential equation before was that the characteristic equation, which we're just going to practice writing like this, had two real roots, two distinct real roots. We do know how to do that. This does extend to any differential equation where the characteristic equation has two distinct real roots. But what about this differential equation, y double prime minus 6y prime plus 9y equals 0? Well, what's that? That's r squared minus 6r plus 9 equals 0 is the characteristic equation, and this factors into r minus 3 squared equals 0. And before we were doing the general solution was, this was r minus 3, r minus 5. So we had 3 and 5 were the roots. This was a, e to the 3t, so the roots go in the exponent next to the t. This is a general rule. It works for all equations of this format. What are we going to do here? If it's 3 and 3, we don't know yet. This is in a future lecture. And then also, what about this differential equation? Y double prime plus 2y prime plus 2 equals 0. What's the characteristic equation there? That's r squared plus 2r plus 2 equals 0. This does not factor. You try the quadratic formula. Maybe it's like ugly real roots, which is fine. You can just put the ugly numbers there. But it's actually worse than that. These are complex roots. Let's just try it. Negative b plus or minus the root of 4 minus 4 times ac is 8, right, over 2a. So this is, we've got the root of a negative number here, right? Complex roots. This actually technically works. You just put the complex roots there and there. But there's an interpretation for e to some complex number, a plus bi, and t, it doesn't matter. There's an interpretation of that that you may not have dealt with yet. So we're going to have a different real value function solution when we talk about this in a few lectures.